In this video, we're looking at rates of reaction, and we're specifically going to look at collision theory and energy profile diagrams. So our learning intention is to explore activation energy profile diagrams, and the effect of a catalyst on activation energy. So to begin, let's look at collision theory. So from junior cert, we would know that a reaction can occur when our reactants and our catalysts must collide. However, it's not that simple that they just need to collide. However, in order for the collision to be effective, it must be one that results in the formation of our products. And a collision is only effective when it occurs at a specific energy. Now, this specific energy is called the activation energy of the reaction. So it's a good idea to look at our definition for activation energy. Activation energy is the minimum amount of energy with which particles must collide in order to form a reaction. Now, activation energy is very important when we are drawing reaction profile diagrams. And a reaction profile diagram is basically a graph which shows the change in energy of a chemical reaction as the reaction progresses with time. So let's take a look at some specific reaction profile diagrams that we need to know for this course. So the first reaction profile diagram that we need to know is for an exothermic reaction. Now, the first thing we should look at is what does the term exothermic mean. So an exothermic reaction is when energy and heat is released to the surroundings. So if we look at our reaction profile diagram here, we can see that we have energy on the y-axis and the reaction progress on the x-axis. So we can see that our reactants begin to react, and once they reach their activation energy, they begin to produce products. So this here, EA, references our activation energy, which is the minimum amount of energy required for the particles to collide in order to produce products. And this delta H here represents the heat change. So as we can see, the amount of energy at the start of the reaction versus the end of the reaction is less. So we know that energy cannot be created or destroyed. So that must mean that the energy is released from our reaction in the form of heat. The next type of reaction profile diagram we'll look at is an endothermic reaction. So for an endothermic reaction, we must know that in endothermic reactions, energy is absorbed from the surroundings. So that would mean that the energy of your products will be higher than that of your reactants. So as we can see here, we have our reactants at the start, and they begin to react together. And once they reach their activation energy, we can see that the products are produced. So this EA here, again, to remind you, it stands for activation energy, and it is the minimum amount of energy required for the particles to collide in order to produce their products. And as we can see here, we have our delta H value, and the reactants clearly have less energy than the product. So we can see that there is an increase in energy throughout this reaction. So that means that energy must be absorbed from the surroundings, and we know this because energy cannot be created or destroyed. The last thing to look at in this video is the effect that catalysts have on our activation energy. And catalysts usually speed up or slow down a chemical reaction without being used up. So catalysts actually provide an alternative reaction route with a lower activation energy. So as we can see here, our blue line is our reaction without the catalyst, and it has a large activation energy. But when a catalyst is added, we have this red graph here, and we can see that the activation energy when the catalyst is used is much lower, which verifies that catalysts provide an alternative reaction route with a lower activation energy. That's it for this video. Have a read over the learning intention to make sure you understand everything we've gone through.